Hello friends, this video on application of integrals part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Let's take one more example. We have to find here the area bounded by here x square is equal to 4 ay, y is equal to 2, y is equal to 4 and y-axis in the first form. So earlier I had y square is equal to x form. Here we have x square is equal to y form. So let's draw this graph. This is my x square is equal to 4y graph. Let's suppose. Then I have y is equal to 2, this line, and y is equal to 4. So I have drawn this line because this guy is, let's suppose, 1, 2, 3, 4. So this guy line is my y is equal to 4 and this line is nothing but y is equal to 2. I have drawn these two lines. Now the question says this guy and y-axis. Y-axis is this axis. This guy. Correct. So if you see what is the common area in this case, the area has to be common between this curve. So let me draw that with a blue pen. Let's do this. My curve that is common between this curve y square is equal to 4ay in the first quadrant. So this is my thing. Then if you see y is equal to 2, so I will draw y is equal to 2 in the first quadrant only. So I am drawing in the first quadrant only. Y is equal to 4, I will draw in the first quadrant like this. And then my y-axis. Y-axis something like this. So if you see, the area which is enclosed by all these blue lines is nothing but, you see, is this area, the one with the stars. Thus I can say this is the area I am looking for, because this is the only area which has all these things, x equal to 2, x equal to 4, this curve and this y-axis. Correct? You can say that if you extend here, why we are not taking this guy? Because in this guy I have y is equal to 2, my curve x square is equal to y axis, but y is equal to 4 is not being in this curve. So the common area has to be the curve which has all this required thing. So this is my area. Now in this case I'll say y vary. Why y vary? Because if I say x vary, my life is difficult, because if I x vary I have to take this area first and this area, because if my x is varying, if I am varying x now, if you see from here to here, my equation of curve is different. Here to here the equation of curve is different, correct? Just understand, if I am saying x is varying, in that case my here to here the curve is this guy, this curve, this curve. From here to here my curve is different, that is y is equal to 2. So that makes my life difficult. So what I am doing is I am saying my y is varying, because if I say y vary, my curve is always same, this guy only, correct? So my life is simple. So let's do this, let's do with this blue color only. So area is nothing but integration of x dy. Now the question is y is varying from what to what? So if you see, y is varying from 2 to 4. So you say y varies from 2. If x square is equal to 4y, x is nothing but root 4y. And that is nothing but 2 root y. So I'll put the value x 2 root y dy. Anyway 2 is constant, so I'll take out 2 to 4. So this becomes 2 into y to the power 3 by 2 by 3 by 2, 0 to 4. So this becomes 4 by 3 into y to the power 3 by 2 is 4 by 2 to the power 3 by 2 minus, this is 2 actually, minus 2 to the power 3 by 2. So if you solve this, this is nothing but 4 by 3 into, this become 2 to the power 3, that is 8, minus, this become 2 to the power 3, 8 root, that is 2 root 2. And that is nothing but, if you see, 32 minus 4 into 2 is 8, 2 root 2 by 3 units, and that is my answer. So it was not that difficult actually, you see. So what I had done, I spent time in drawing the curve, and then I also spent time in analyzing which area I am looking for. Then I found that I am looking for this area, the area in the stars. And then I found that if I make y vary, my life is simple, because there is only one curve. if I vary from y from 2 to 4, but if I make x variable, if my x is varying from, let's suppose, from here to here, I see there are two curves. One is from here to here, one is from here to here. So that in that case I have to find two areas and add, but I didn't want to do that, so I made y vary. Let's take one example. Here we have to find the area of the region in the first quadrant. Please note, first quadrant enclosed by x-axis, line x root 3, y, and this circle. So I have this my x, y axis, and let's draw a circle because this is nothing but circle with 0, 0, this one center, and 4 radius. So 1, 2, 3, 4, almost that circle I have made this. Now let's draw this line x is equal to root 3y, that is line is passing from 0 to 0 because x is equal to root y meets that condition and has a slope root 3. And also x-axis, this guy. So what is the area I am looking for? Let's again draw in the blue one. First quadrant, so I'll interested only in first quadrant. X-axis, let's draw the x-axis with the blue. Correct. Then my line x root 3y, let's draw with the blue. And then circle x square is equal to x square plus y square is equal to 4. I can draw the whole thing, but I see the intersection is only this area. So let's draw this only. Correct. Even if I draw this, it doesn't make sense. So this is my area I'm looking for. Now if you see, the trick part here is, even if you vary, for example, with x or with y, with y you can't vary actually. Why? Because you see, with respect to y you don't have this curve actually. So with x it will only you have to vary. But the trick part here is, even if you vary with x, the function is not same, because from here to here, this point, my function is, y function is this, and from here to here my y function is this. So my function is also varying. So I have to say this is area 1, this is area 2. So I'll say area required is nothing but area 1 plus area 2. Correct? This guy is area 1, this guy is area 2. And I have to find both the areas. So area 1 will be nothing but, if you see, I'll just write here, area 1 is nothing but y dot dx for this curve. This line is what? Y is equal to root 3y. Sorry, y is equal to 1 by root 3x. Correct? So this becomes actually 1 by root 3x dot dx, and x varies from 0 to this point. 0 to this point. What is this point? So we have to first find that point also. So this point is nothing but, if you see this point, if you can find and this point is nothing but intersection of this line, that is x is equal to root 3y, and this circle, right? This point you can find, the x coordinate is same in these 2 points. So I can find this x coordinate because this is critical for me now. And what is the value of this x coordinate? 2. Why? I know this is 2 and y is 0. Why? Because the length is 2, radius is 2, x square plus y square is equal to r square. So this is 2. So to find this guy, to find the intersection of this circle and this line. So let's first find the intersection. Then only I can put the value here, right? And if I have this value, let's suppose this value is x, which I'll find now, or x dot. This guy is x dot. I'll find the value of x dot now. And then a2 will be nothing but, again, y dot dx. But in this case, my y is different. Y here will be, if you see, this is this curve here. For this curve, y is nothing but root of 4 minus x square. Correct? This guy goes here, 4 minus x square, you take root. So this guy will be root of 4 minus x square, and integrate this guy here, it will be from x0 to 2 dot. Correct? Integration is simple. The only critical part here is now finding the value of this point, x0. Right? This guy is x0 plus y0, let's suppose. So this guy is also x0. and y is 0 here actually. So this guy is x naught comma 0. So let's find x naught, y naught. So x naught, y naught is nothing but point of intersection of these two curves. So let's do x square plus y square is equal to 4 and x square is equal to 3y square. I just squared this guy. So point of intersection of these two. So let's write here x square plus x square is equal to 3y square, correct? So let's put x square as 3y square here. So this becomes 3y square plus y square is equal to 4, or I get 4y square is equal to 4, or I get y is equal to 1. If y is equal to 1, my x will be nothing but, y is equal to 1, x will be nothing but x is equal to root 3 y, that is root 3 into 1. So this guy is root 3. So x naught is root 3 comma 0, and this guy is root 3 comma 1. So I don't need y naught, so leave it. So I have this point now. So my area is nothing but a1 plus a2, correct? That is this guy plus this guy. So this guy is y1 dx, that is 1 by root 3 x dx from 0 to x naught is, I know, root 3 a1 plus a2, that is root of 4 minus x square dx from root 3 x naught to 2. I have to just find the value of this. This is 1 by root 3 common outside because it's constant. This becomes x square by 2 from 0 to root 3 plus this becomes 4 minus x square, integration becomes x by 2 root 4 minus x square plus 4 by 2 sine inverse x by 2, and here this varies from again root 3 to 2, 0 to root 3, root 3 to 2. So this becomes actually 1 by root 3 into root 3 into root 3 by 2 plus this guy is, you have to solve, it's 2 by 2 root 4 minus 4 plus 4 by 2 sine inverse 2 by 2 minus, here is root 3 now, root 3 by 2, root 4 minus root 3 square is 3 minus 4 by 2 sine inverse root 3 by 2. That is what you get. So this becomes root 3 by 2 actually, correct? Plus this we have to find. So this is what x 2 by 2 is 1, this is 0 anyway. Sine inverse 1 is pi by 2, so this becomes 2 into pi by 2, 2 into pi by 2 y 2, 4 by 2 is 2 minus this becomes root 3 by 2 into 1, correct? That is root 3 by 2 minus 4 by 2 is 2, sine inverse root 3 by 2 is pi by 3. So if you add everything, what you get is pi by 3 pi by 3, because root 3 by 2 minus by 2 cancel, and this is pi, this is 2 pi by 3, subtract, you get pi by 3, and the difference. So here also what we observed was the difficult part was drawing this curve and finding that we have to find this particular area. Once we know that we have to find these particular areas, we got this area and this area, we divided this into two area, A1, A2. We found area of this, area of 2, and then for this we have to find this point where this is changing, these curves are changing. I found that at x is equal to root 3 is changing, so I integrated this from 0 to root 3, this curve, and root 3 to 2, this curve we integrated. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.